Imagine you just wrapped up a school project on the flat Earth theory, and then plot twist, you find out it might not be as crazy as it sounds. Buckle up, because we're about to take a wild ride into a world where the Earth is flat and things get interesting. So let's put on our thinking caps and see just how wild this flat world can get. The end of the flat Earth, gravity's rule. First, let's address the most immediate concern. How long would the Earth stay flat? The answer is not long at all. In a flat Earth scenario, gravity would soon play its inevitable part. Gravity is a force that pulls objects toward the center of mass. On our spherical Earth, gravity pulls everything toward the center of the planet, shaping it into a nearly perfect sphere. But in a flat Earth model, the force of gravity would act very differently. Gravity, which is responsible for the spherical shape of all the planets, would not be uniform. It would pull more strongly at the center of the flat disk, attempting to mold it into a round shape. In fact, gravity wouldn't let the Earth remain flat for long. Within hours, the force of gravity would begin pressing everything towards the center, gradually turning the flat disk into a spherical shape, much like the other planets in our solar system. In reality, gravity is one of the fundamental forces that creates and maintains the spherical shapes of planets. Gravity pulls equally in all directions, and that's why large celestial bodies like Earth and other planets are shaped into spheres. For a planet to remain flat, gravity would need to be absent or severely weakened, but even a slight presence of gravity would quickly push the flat Earth back into its spherical form. Gravity, therefore, is a force that has been a crucial part of Earth's existence for billions of years, and its pull would make a flat Earth unsustainable. It's fascinating to think about, but gravity wins out every time. The collapse of the atmosphere. But what happens if gravity doesn't completely disappear? While it's true that gravity would still be present in the center of the flat Earth, it wouldn't be enough to keep the entire planet stable. One of the most immediate consequences of a flat Earth would be the collapse of the atmosphere. Our atmosphere, which is composed of nitrogen, oxygen, carbon dioxide, and other gases, is held in place by gravity. On a spherical Earth, gravity pulls air toward the center, keeping it evenly distributed. But on a flat Earth, the distribution of gravity would be all wrong. Gravity would pull more strongly toward the center, leaving the edges of the planet devoid of atmospheric pressure. This would lead to catastrophic consequences. Without an atmosphere, the Earth would become uninhabitable. The lack of air would mean no oxygen to breathe, and without oxygen, humans and all other living species would perish. The sky would become dark as sunlight would not be able to reach the surface properly. Moreover, temperatures would drop dramatically. Earth would become a frozen wasteland. The absence of an atmosphere would also mean that harmful solar radiation would directly reach the surface, causing further harm. This is not a hypothetical issue. It's what scientists believe could happen if Earth lost its atmosphere. So while a flat Earth might sound intriguing, it would certainly lead to a quick and irreversible downfall. The pull toward the center. Gravity's curious behavior. Let's say gravity doesn't completely disappear. Instead, it would behave very differently. Everything on a flat Earth would be drawn toward the center of the disk. Imagine walking away from the center. Every step would become increasingly difficult as gravity pulled you back toward the middle. The effect would be similar to what we experience on Earth, but with a unique twist. Objects, including people, would no longer fall downwards, but sideways. Rather than falling straight down, objects would be pulled in the direction of the strongest gravitational pull, the center of the Earth. This would cause rivers, seas, and oceans to behave in strange ways. Water in the oceans and rivers would flow toward the center of the Earth, creating vast bulges of water in the middle of the flat disk. The edges would be left dry, with little to no water at all. The lack of water would present an existential challenge, as much of the water that sustains life would be trapped in the middle of the planet. Air pressure, a breathless existence. In addition to the movement of water, air would also behave oddly in this alternate flat Earth. Since gravity would pull air toward the center of the flat disk, there would be no air pressure at the edges of the planet. Without air pressure, there wouldn't be enough oxygen to breathe, and life as we know it would be impossible. Imagine trying to take a breath at the edge of this flat Earth. There would be nothing but thin air or even a complete vacuum. The very idea of living on such a planet seems impossible because without air, survival would be out of the question. The end of the Earth's magnetic field. As we've all learned from science classes, Earth's magnetic field is crucial to life on our planet. It serves as a shield, protecting us from the harmful effects of solar radiation. The magnetic field is generated by the movement of molten iron and nickel in the Earth's core. This movement creates electrical currents, which in turn generate a magnetic field that extends from the core and beyond, forming what is known as the magnetosphere. The magnetosphere protects the Earth from solar winds, which could otherwise strip away the planet's atmosphere. However, on a flat Earth, this magnetic field would not exist. The dynamic process that generates the magnetic field requires the rotation and spherical shape of the planet. Without the rotation of a spherical Earth, there would be no movement of molten metals to create this protective shield. Without a magnetic field, the Earth would be vulnerable to solar wind and cosmic radiation. These particles could strip away the atmosphere, exacerbating the problem of having no air to breathe. The consequences would be severe, and it would make the Earth even less habitable than it already is in a flat Earth scenario. The death of day and night. Now, let's talk about the concept of day and night. In our spherical Earth, the tilt of the planet and its rotation around the Sun create the cycle of day and night. On a flat Earth, however, there would be no such cycle. The Sun, which in our reality rises in the east and sets in the west, would behave quite differently. In a flat Earth scenario, the Sun would move in a circular path above the surface, similar to a giant spotlight. It would hover over one part of the planet for a prolonged period, while other areas would remain in perpetual darkness. This would mean that there would be no distinct division between day and night. Imagine living in a world where the sun never truly sets. Your sleep schedule would be completely thrown off, and the concept of a good night's rest would become a thing of the past. Additionally, regions near the sun spotlight would experience constant daylight, while others would endure endless nights. This uneven exposure to sunlight would drastically affect temperatures, ecosystems, and human life, making it nearly impossible to sustain the balance required for thriving civilizations. The absence of the day-night cycle would create chaotic environments, disrupting agriculture, wildlife, and human biology, making life as we know it unsustainable. A fascinating reality. Despite the bizarre consequences of a flat Earth, there's one thing we can all agree on. Earth is perfectly designed as it is. It's round, with a magnetic field that protects life, an atmosphere that sustains oxygen, and a day-night cycle that keeps everything in balance. The science behind the Earth's shape, gravity, and magnetic field is what allows us to live on this planet. And if things were different, life would be far more difficult, if not impossible. In fact, the true shape of the Earth is not a perfect sphere. The Earth is technically an oblate spheroid, which means it's slightly flattened at the poles and bulging at the equator due to its rotation. This unique shape helps maintain the balance we depend on. Without this delicate balance, life would be far more difficult, and our planet would not be able to support life in the way it does now. If you enjoyed this mind-bending journey into a flat Earth, don't forget to hit that like button. Let's see how many of you are brave enough to challenge gravity. And if you want more wild theories, subscribe and join the adventure. Until next time, keep your curiosity as round as our planet.